Hello, thank you for visiting Deloach Education on YouTube. I'm Gary Deloach. In this video, I will demonstrate how to multiply decimals using the standard algorithm. The first two examples I will complete will involve a detailed process of using the standard algorithm. The last two examples I'm going to work are going to be using a shortcut method of using the standard algorithm. So, let's get to it. The first thing I'm going to point out is that multiplying decimals is a lot like multiplying whole numbers. The only thing you need to do is just ignore the decimal point. Don't let it confuse you. Don't let it intimidate you. It's the same process. So what we're going to do first in dealing with that decimal is we are going to make sure that both factors are a whole number. So what that means is we can leave 754 alone because it is a whole number. We're going to turn 2 and 5 tenths into a whole number by multiplying it by 10. 2 and 5 tenths times 10 is 25. And for that step, I want you to recall the rules for multiplying and dividing by powers of 10. Remember, when you're multiplying by powers of 10, the shortcut is to move the decimal to the right, according to the power of 10 or the exponential form of the power of 10. And when you're dividing, you're going to move the decimal to the left according to the standard form of the power of 10 or the exponential form of the power of 10. So we have both numbers as a whole number, so I'm going to go ahead and just start multiplying. 5 times 4 is 20, carry your 2. 5 times 5 is 25 plus 2 is 27, carry your 2. 5 times 7 is 35 plus 2 is 37. We're going to put in a 0 here, and that's because we're multiplying by the second digit. In this case, it's a 2, and it's in the tens place. So 2 times 4 is 8. 2 times 5 is 10. We're going to carry our 1. 2 times 7 is 14, plus 1 is 15. And then we're going to add. 0 plus 0 is 0. 7 plus 8 is 15. Carry your 1. 7 plus 1 is 8. 3 plus 5 is 8. And then we have 1. So our answer looks like it should be 18,850, but what we have to take into consideration is that we multiplied 2 and 5 tenths by 10, so now we got to undo that process, and we're going to do so by dividing the answer by 10. So when we divide our answer by 10, we end up with 1,885. And what really happened was that decimal moved one place to the left. So it ended up between the 5 and the 0. Alrighty, so let's take a look at example number 2. In example number 2, we have 3 and 57 hundredths, and we're multiplying it by 12 hundredths. So again, the first thing we want to do is make sure both numbers are whole numbers. In order for both numbers to become whole numbers, we need to multiply them by 100. 3 and 57 hundredths times 100 is 357. That decimal moved 2 places to the right. 12 hundredths times 100 is 12. That decimal moved 2 places to the right. So now we're just going to multiply 357 and 12. So 2 times 7 is 14, carry your 1. 2 times 5 is 10, plus 1 is 11, carry your 1. 2 times 3 is 6, plus 1 is 7. Put in a 0. 1 times 7 is 7. 1 times 5 is 5. And 1 times 3 is 3. So we're going to find the sum of those two partial products. We have 4 plus 0, which is 4. 1 plus 7, which is 8. 7 plus 5, which is 12, carry your 1. And then 1 plus 3, which is 4. So it looks like our answer should be 4,284. But remember that we multiply both factors by 100. So if you think about the product of 100 and 100, it is 10,000. So what we're going to do to get our final answer here is we're going to divide 4,284 by 10,000. And dividing it by 10,000 is going to give us a final answer of 4,284. And I can very well show that decimal moving 4 places to the left. So our final answer is, I didn't say it correctly earlier, it is 4,284 10,000ths. Alrighty, so let's jump into some standard algorithm with some shortcuts. So we have the number 235 and 7 tenths. I did not worry about lining up the decimals. I lined up the digits, and now I'm just going to multiply. 7 times 5 is 35. Carry your 3. 7 times 3 is 21, plus 3 is 24. Carry your 2. 7 times 2 is 14, plus 2 is 16. Now, to figure out where the decimal goes here, we are going to count the number of digits to the right of the decimal points in both factors, and that is the number of digits we should have to the right of our decimal point in our answer. So, 1, 2, 3, 1, 2, 3, and our final answer for this problem is 1 and 645 thousandths. And in the last example that we're going to complete, it is 88 and 800ths times 22 hundredths. All right, so in this last example, we have 88 and 8 tenths, and we're multiplying it by 22 hundredths. So what I'm going to do is ignore the decimal points, and I'm just going to multiply them as if they're whole numbers. 2 times 8, 16, carry a 1. 2 times 8, 16, plus that 1 is 17, carry your 1. 2 times 8, 16, plus 1 is 17. I'm going to put in a 0 because multiplying by the second digit, or the digit in the tens place, if they were whole numbers. 2 times 8, 16, carry your 1. 2 times 8, 16, plus 1, 17, carry your 1. 2 times 8, 16, plus 1 is 17. And now we're going to find the sum of those two products. So 6 plus 0 is 6. 7 plus 6 is 13, carry your 1. 7 plus 7 is 14, plus 1 is 15, carry your 1. 1 plus 1 is 2, plus 7 is 9, and then I just add 1. So, if you look at the number of digits to the right of the decimal points in the factors, you have 1, 2, 3 digits. So therefore, in your answer, you will also have 3 digits, giving you a final answer of 19 and 536 thousandths. Thank you for watching this multiplying decimals video on Deloach Education. If you have any questions, feel free to drop them in the comments, or you may email me at deloacheducation@gmail.com. See you next time.